Last time when we were here, we were talking about how we can find the center of mass of a more general shapes, right? Such as like cubes or cylinder, right? Or block of cheese, or if you were to look at geometric center, as long as the object has a uniform density, it's going to make sense to have the center of mass located at its geometric center, right? Therefore, if we were to look at something more general shape, okay, how do we find that? I think I told you how to find two-dimensional one, right, by hanging a piece of paper, I think an index card that I cut out, right, and then if you were to put a push pin in one of the parts and then let it hang, and then if you were to find the vertical of that by placing a plumb bob on that same pivot point, you should be able to draw a line straight down. Then you repeat that on the second part in some other place. Then whatever those two lines intersect, basically uh, represents the center of mass of that two-dimensional flat shape, right? Now, let's say we have something like this where we have pieces cut out, right? Missing pieces. Most likely we can do the same thing, but if we could do this mathematically, I think it'd be even easier, right? So as long as the object has uniform density, we can use that idea instead of placing a mass inside. Since we don't know what the mass is, we could actually use the uniform density and you replace density for mass, right? So maybe we could write that down. So always use density, right? To sub in for the mass. Okay? So, if it's three-dimensional object, uniform density is represented with rho, and rho is equal to mass divided by volume, and sigma is mass divided by the area, and lambda is mass divided by length, right? So in our particular case, we're going to use actually volume, right, because it is three-dimensional shape, okay? So if we were to look at where we're going to place the center of mass for this particular object, right? In the example, I'm going to put this here as our reference point 0, comma 0. Okay? So if this here were 0, comma 0 as our origin, right? Where would the center of mass of this cutout versus this would be relative to this origin, all right? So this location here would be negative r comma 0, okay? And here would be negative 2r comma 0, and here would be 2r comma 0, and so on, right? So here will be, I'm going to consider this solid disk without the hole, right, to be my mass M1, right? And the hole that I cut out will be my M2, all right? And we're going to subtract this mass minus the cutout mass, like that. And this will be the composite of it, right? So when we cut this much out of this, we'll get that. All right, so now because of symmetry in the y direction, we're not going to really worry too much about the y, only worry about the x, right? Because you know it's going to have to be along this direction here on the x-axis for the center of mass, because in the y direction, the symmetry is involved, right? So this side, positive y section, is exactly the same as the negative section of the y. So let's take a look at just the x direction, all right? And that is, right, m1 x1 minus m2 x2, divide that by m1 minus m2. All right? So, but what is m, right? Well, since we know mass, so rho times the volume, right, is equal to the mass, right? So m1 is equal to rho times volume 1. m2 is equal to, right, rho times volume 2. So how do we get the volume 1? Well, volume 1 is, right, is this right here, right? Volume 1. And that is really nothing more than pi r squared times the thickness d. But the r itself is 2r, right? So pi times 2r squared d, which is, right, 4 pi r squared d. That's volume 1. Volume 2, right? Volume 2, which is this. So volume 2 would be same thing, but it would be just r squared, right? So m2 would be rho times pi r squared thickness d. All right? So it's good to know, right? So rho times 4 pi r squared d for m1, and m2 will be just this. So if we replace these in here, right, m1, which is rho times 4 pi r squared d, times x1. x1 is 0 because it is located, the center of mass of this big object is located 0, 0, minus, right, rho pi r squared d times x2 will be represented as negative r. Whole thing divided by m1, which is rho, I'll put the 4 out in the front, rho 4 rho pi r squared d minus rho pi r squared d. Well, this goes to 0, and this becomes plus because we've got negative r and negative here, okay? And we're going to get rho pi r squared d times r. Now, I did not multiply this r through because I'll show you why. Because we can actually have just 3 rho pi r squared d. As you can see, this and this can be canceled out. So our x sub cm is equal to 1/3 r. So where would this be located? So here is r, and this is r, right? 0, r, 2r. So 1/3 r will be right here. That will be the center of mass. All right. All righty. Now that I showed you that, okay, let's see if we can do the next page. See if you can try this. Now, I'm going to say make this origin or reference point 0, 0 right here. Here. You could make it here if you want to, right? But if you do it here, won't it just like eliminate one of the calculations? So make this your 0, 0. Okay? And I'll give you 5 minutes. See if you can just set it up, and then we'll go over it. All right? I'm just gonna get me a cup of coffee. So 5 minutes. Come on, I'll meet you back in 5 minutes. All right. How are we doing? Good. All right. Think about this as M1. Think about this as M2. Okay? The center of mass of this is actually 1, 1, right? So M1 is equal to rho times volume 1. And volume 1 is really nothing more than 6 squared times thickness D, right? Which is 36 rho D. M2, however, is equal to rho times volume 2, right? So that is equal to, so this is M1, rho times pi r. R happens to be 1, right? So R happens to be 1 meter. And so pi r squared d. Therefore, pi rho d will be my m2. All right. So let's take a look at in the x direction first. Right? So the center of mass in the x direction is equal to, right, m1 x1 minus m2 x2. Divide that by m1 minus m2. Therefore, m1, which is 36 rho d, times x1, 0, minus m2, which is pi rho d, times x2 is just 1. Right? Divide that by 36 rho d minus pi rho d. That is then, right, well, negative pi rho d over, right, 36. I'm going to factor out the rho d, so it would be 36 minus pi. So this rho d and this rho d should cancel out, giving you, right, negative pi over 36 minus pi is what you should get for x sub cm. Now for the y, you could see it's going to be the symmetry right here in the y is going to be same as your, well, let's do it. So y sub cm, right, is equal to m1 y1 minus m2 y2 over m1 minus m2. You could see the symmetry because here m1 again is 36 rho d times y1 is 0, right, minus, right, pi rho d times y2 is just 1, right, again, that looks identical, over 36 rho d minus pi rho d, right? So you know that you're going to have negative pi over 36 minus pi for y center of mass, okay? So you can say, okay, r sub cm is equal to, right, negative, right, pi over 36 minus pi I hat minus pi over 36 minus pi j hat as your center of mass. All right. Good. Any questions? All right. Let's take a look at the next one. for this? Well, let's do it differently this time, just so we can say, all right, I'm going to place origin at this corner at the bottom. I mean, it'd be easier, I guess, if we were to put the right in the center, smack in the center, right? But let's just do it for fun. What would happen if I were to do it right in the corner as my, okay, so here is my x-axis, right? And here's my y-axis. Okay, and this location here is, let's say, 0, comma 0 at this point, right? And here's 1, here's 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay? Similarly, here is 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. Okay? Now, where are the center of mass for each block? Right? Each block. Assuming that each block, I'm going to just make it easy. So let's make, right, each block 2 meters by 2 meters with m is equal to just 1 kilograms. 1 kilogram for each block. All right. And it's, of course, uniform density, right? Uniform density. So here we know the center of mass is located in its geometric center, right? So each of these blocks will have center of mass right smack in the center, like so, right? That's missing a couple of teeth right here, right? So we can find the center of mass in the x direction first, and then find the center of mass in the y direction, see where they end up. Okay? My prediction is it's going to be along this line, obviously, because of symmetry. And it's going to be above this line because we're missing some pieces here, so we're going to have to, bring it up here somewhere to balance the point. Right? If I were to balance this thing, this way, it's going to have to be on this line. But this way, right, it's going to have to be somewhere above this line because it has to balance out, because this side will be heavier by these two. So I'm predicting somewhere around here, right? Somewhere around here. So let's see if that's true. So we know the x sub cm just by default. It's going to have to be 4, right? But let's work it out. So x sub cm is equal to, right? I have 1, 2, 3, 4, 4 times m1, which is 4 times an x1, right? And then 3 times x3, so plus 3 times 3. And then 3 kilograms times 5, right? And 4 kilograms times 7, right? Whole thing divide by, right? I have 4334, right? So my x sub cm is equal to, well, it looks like I got like 4 plus 9 plus 15 plus 28, whole thing over, right, 14, right? So what is that equal to? Well, let's work it out. So it looks like 4 plus 9 plus 15 plus 28, right? Ah, crap. So 4 plus 9 plus 15 plus 28. 56 over 14, right? So divide that by 14. And I get 4, just as we predicted, right? So x sub cm is equal to 4 meters. I had. What about y? So y sub cm is equal to, right, 2 kilograms times 1, right? 2 kilograms times 1 plus 4 kilograms times 3, right? Plus 4 kilograms times 3 plus 4 kilograms times 3, right? Whole thing over 14. Right? So y sub cm is equal to, I mean, we already know this is going to be 14. It's not going to change, right? So here, 2 plus 12 plus 12 plus 12, which is 36, plus 2 is 38, right? Divide that by 14, and I get something's messed up. Oh, I'm sorry. This should be 5 and 7. I knew something was messed up. This 7, right? So 3, and then 5, and then 7. Sorry. I knew something was messed up. So here we go. So we get 2 plus 12 plus 20 plus 28, whole thing over 14. Right, so 234 plus 28, and we get 62 over 14. And that is equal to, I get 4.43. So my y sub cm is equal to 4.43 j hat. So for my x is 4, and then 4.43 is a little less than 4.5, so right around here is my center of mass, right? This is 4 comma 4.43. Right? So that's where my x sub cm lies. So my r sub cm is equal to, right, 4 I hat plus 4.43 j hat. meters. All right. Now you guys do this one. Let's go. I give you 5 minutes. Do it here again as your zero. Make your zero at the corner. Okay, right here, so that we all have the same answers. I know it'd be easier if you put it somewhere around here, but it really doesn't matter in this case. So here is your y. All right. Keep the things the same boxes, 1 kilogram for each box, and they're 2 by 2. Right, so here's your x. Okay. Now think about where these are. Okay. So here is your 0, 0. This is your 1, 2, 3, 4, 5, 6, 7, 8, all right, and so on. So here's your 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. All right. And of course, the center of mass will be in this geometric center, geometric center, geometric center, right? But for these halves, it still has to be at geometric center, right here. Geometric center. So keep that in mind. Again, the x should be easy. So come on, 2 minutes. All right, so let's take a look. Let's take a look at the x first, which is the easier one, right? So x sub cm is equal to here, right, it looks like 3, 1, 2, 3 at 1.
Your mic is muted.
Ah, thanks. So in the x direction, I have 3 kilograms at 1 meter in the x, right? So here I have 3 kilograms times 1. And I have 3 kilograms times 3. Same thing, but 3 kilograms times 5. And then 3 kilograms times 7. Right? Whole thing divide by, it looks like 3 plus 3 plus 3 plus 3. Therefore, all this mess will be like 3 plus 9 plus 15 plus 21 over, right, 12, right? So what is that, John? So 3 plus 9 plus 15 plus 21 divided by 12. And of course, we're going to get 4, right? So it's called 48 divided by 12, which is 4 meters. So my x sub cm comes out to 4 meters I hat, which, as we predicted. Now for y, it's slightly different, I guess, right? My y sub cm, I'm going to need more room probably. So here, it looks like 2 times 1, right? 2 kilograms times 1 plus. Here, it looks like 1 times 2.5, right? Because I got half here, 1 times 2.5. Then I have 2 times 3, right? Then 2 times 5. Here looks like 1 times 5.5. And then 4 times 7. Whew. Whole thing divided by, now obviously it's going to be 12, but if you want to, you could say 1 plus 2 plus 1 plus 2 plus 2 plus 1 plus 4, right? Or just 12. It's not going to change. So your y sub cm, right, is equal to, right, 2 plus 2.5, right, plus 6 plus 10 plus 5.5 plus 28 over 12. All right. Therefore, if you work it out, so 2 plus 2.5 plus 6 plus 10 plus 5.5 plus 28. Whoa, 2 plus 2.5 plus 6 plus 10 plus 5.5 plus 28. And I get 54 over 12. So divide that by 12, and I get 4.5 meters. So your y sub cm is equal to 4.5 meters j hat. So your r sub cm, right? So your r sub cm is equal to right? 4I hat, right? Plus 4.5 J hat meters. Okay? I hope that's understood. All right. So what happens when there's internal movements in a system, right? Let's say something's moving inside. Wow. Wow. Let's take a look what happens when that happens. Okay? So if we have something in internal movements, if you ever go kayaking or if you ever go canoeing and you try to stand up and switch places, or sometimes if you just stand up and go to one side, what happens to the canoe, right? Or if you're standing on one of those flat cart from Home Depot, right, and then you walk on it, what happens to that flat cart, right? You would actually move. And in doing that, it keeps the system of the center of mass system, right? The center of mass system will not actually move relative to the stationary position. Okay? So let's take a look at three particle system below. We have mass 1 of 100 kilograms, right? So this bubble person has 100 kilograms of mass, right? Mass 2 is 30 kilograms of mass. And mass 3, which is the platform, or is 50 kilograms of mass, right? Let's find the center of mass of this three particle system, okay? So where are they all located? Here's 2 meters, 5 meters, and 8 meters, okay? So the center of mass okay, is equal to um, m1 x1 plus m2 x2 plus m3 x3, right? Well, this is m3, m2, and m1. All right. So, what is that equal to? Well, that is equal to m1 is 100 kilograms times x1 is 2 plus, right, m2, which is 30 kilograms times 8, and m3, which is 50 kilograms times 5, right? So this is 50, 30, and 100. Therefore, when you work it all out, you get 200 plus 240, right? Plus 250, right? Divide that by 180, right? So that is 690 divided by 180, and that comes out to 3.83 meters. X hat, obviously. Right? So now let's take a look at what happens. Okay. So that is located now. So the center of mass is located right around here. Right? That's the center of mass. Okay. So now what happens when mass 1 walks to the other side of the platform to 10 meters, right? And then mass 2 walks to 7-meter position, right? How much does the platform shift and in what direction? Okay, so let's find out where the center of mass is for this particular system, right? And see where this center of mass lies, right? So x sub cm is equal to, now again, right? I'm not going to write this, the same thing, right? I'm going to start from here, all right? So here I get m1, which is 100 times 10, and m2, which is 30 times 7, right? And m3 is 50 times 5. So at the bottom, you're still going to get 100, right? 30 and 50. So if you work that out, the top goes 100 plus 210 plus 250, right? So 100, 1000 plus 210 plus 250. Whole thing divided by 180. So here you get 1460. Divide that by 180. Okay? So what do you get? I get 8.1 repeating, right? So the center of mass comes out to 8.11 meters, right? I hat for this one. So it's going to be somewhere here. This is the center of mass. If I were to line these up, this center of mass point and this center of mass point should line up, because center of mass of the system will not change because there were no external forces. So this whole thing has to shift over this much. So this center of mass and this center of mass lines up right here. Okay, so that if I were to draw the center of mass straight down, this center of mass point should have shifted so that this is right at the same spot as where it was. Okay, so this thing would have shifted to the left, right? This minus that much. Okay, the Okay, so if I were to sort of like reiterate what I'm saying, let's just pretend that this is the original platform, right? And we have the bubble person here, another bubble person here, and then that. And the center of mass was at 4 3.83, right? So it was here. Okay. So this center of mass position relative to outside does not change. So when this thing shifted, right? Now and I have that 100 kilogram person here, right? 7 kilogram person here. No, 30 kilogram person here. And then this is here, right? This center of mass of the whole system still does not change relative to the outside. So this and this, right? If you were to look at, these are the most, consistent, stable position here. So this thing shifted 4.28 meters, right? From here, this whole thing shifted 4.28 meters to the left. Okay. I hope that makes sense. Okay. So relative to this is at 8.11. This at 3.83 relative to the platforms. But relative to outside, the center of mass position did not change. Okay? It's very important to understand that. All right. Now that I showed you that, let me see if you guys can do the next 2 pages. All right. So, this is your homework problem, but get it done now so we can get this done and out of the way today because we are a little bit behind Doc. So consider 3 people standing in this, given positions here, right? I've got mass 1, 80 kilograms. The mass of the platform is 90 kilograms, right? And then mass 2 is 50 kilograms. Mass 3 is 25 kilograms. All right? So let's calculate the center of mass. All right. I'll, I'll pause the video, I guess. Nah, I think I'll leave it. All right, let's take a look at this one. Okay. I mean, obviously the x sub cm should be really easy, right? We should be able to calculate that, no problem. So I'm going to go with just one color today with this. So we have x sub cm is equal to, right? And this is initial and this is final, right? So let's make this initial. Maybe I'll do a different color for the final after they move around, okay? So here, it looks like 80 times 1, right?
Mr. Kim, I think you're muted.
Oh, thanks again. All right, so 80 times 1, right? And then plus, looks like 90 times 4 plus 50 times 5 plus 25 times 7, right? Whole thing over 80 plus 90 plus 50 plus 25, right? And if you work it out, okay, I mean, I'm not going to do this thing, whole thing, a calculator here. I mean, you should be able to do this. Hopefully you got 3.53 meters for your initial center of mass position. Okay, so 3.53 is right around here somewhere, right? All right. Now, the second part is now this thing has moved because this mass 1 went over to mass 7, right, and lifted mass 3 up in the same position. And mass 2 decided to go to where mass 1 was. All right. So let's take a look at x sub cm final. And that is here. What is that? M2 is 50 times 1 plus 90 times, I guess you could say 4, plus, here I have a combined mass of 80 plus 25, which is 105, times 7, right? This whole thing divide by, I guess, what is that? 171, 220, and then 220, 245, right? So 245. So if you work that out, I think you'll get 4.67 meters ahead. So here, it'll be located around there for your center of mass. So this has to line up, right? This has to line up. So it has to shift this way so that so this and this lines up, okay? So it has to shift this way to the left, right? So the delta x is equal to, right, 4.67 minus 3.53, and that is 1.14 meters shift to the left. Okay, because it has to line up. These have to line up. So the best thing to do is, like, I will put like a ruler down and see, like, oh, this has to shift over. Okay, it has to shift over. Now obviously this is not lined up like this, but it has to shift over to the left. All right. Now comes something really different. What if this thing is, what if the things are in motion? What if the things are in motion? Now I have 10 minutes, obviously. So I'm going to do my best to get this thing done in 10 minutes. Then I'll let you do the other page on your own as your homework. All right, so here we go. Block 1 with mass of 1 kilogram is initially at the origin, and block 2 with mass of 2 kilograms is initially at 3 meters, right? Now, both starts from rest. So we could say the initial velocity VI1 is 0, right? And VI2 is also 0, okay? Now, force 1, which is acting on M1, is 3 newtons. It'd be nice to have some units down. So 3 newtons of force is acting on M1. So my F1 is equal to 3 newtons. Okay? And force of F2 is acting on M2 with 12 newtons. So they're going to be both accelerating at 2 different rates. Okay? And all this is happening. So what is the acceleration of this John? Right? So F1 has, so M1 has acceleration 1, right, of 3 meters per second squared, right? X hat, right? And M2 has acceleration of, right, 6 meters per second squared, right? And they're both in positive directions, obviously, because they're going in, pulled in a positive direction, right? And the initial velocity, V1 initial, right, is equal to 0 meters per second. And V2 initial is equal to 0 meters per second. That's good to know, right? Now they're asking, right, what is the acceleration of the center of mass? The acceleration of center of mass, I'm going to do that in green, right? So the acceleration of center of mass is equal to M1 A1 plus M2 A2, right? Divide that by M1 A1, right? I mean M1 M2, I mean. Right? Boom. So what is that? That is equal to, right, M1, 1 kilogram, times A1, which is 3, right? M2, which is 2, times A2, which is 6, and M2 is 2. Right? So 3 plus 12 divided by 3. So that is 3 plus 12 is 15 divided by 3 is equal to positive 5 meters per second squared. X hat is my acceleration of center of mass. So as these are accelerating across, the center of mass's acceleration is accelerating at 5 meters per second squared. Okay? So first find acceleration for the system when you do this. Okay? So you can even write that down if you want to. Use F equals ma to find, right, acceleration for each mass. Okay? Then V sub Cm. We should find V sub Cm, what's going on with V, right? So use Vf is equal to Vi plus At, right? To get, right, V of t equation respect to time for each mass. Okay? Therefore, for M1, right, we have V1 final is equal to V1 initial plus A1t, right? So basically, V1 final, which is V of t, V1 of t is equal to, you know, this goes to 0 because it is starting from rest, right? And A1 is 3, so we have positive 3t. Okay? And for M2, we have V2 final is equal to V2 initial plus A2t. Therefore, V2 of function t is equal to positive 6t, because you know this initials goes to 0. If it doesn't start at 0, you have to put whatever that value is in there, right? Therefore, my center of mass velocity will change because they're both accelerating. So it's going to depend on time. At what time it is, my velocity value will change for both masses, which means my velocity value of a center of mass will also change. All right. Therefore, if I were to do V sub Cm is equal to M1 V1 plus M2 V2 over M1 plus M2. Since I'm running out of time, I'm not going to change the colors here. So M1 is 1, right? V1 is basically 3t, right? Plus M2, which is 2, right? Times 6t, right? Whole thing over, right? 3. Therefore, 3 plus 12, right? What is that? 15, right? So 5t meters per second x hat is what I get for my V sub Cm. Okay, so this is my V sub Cm. This is my A sub Cm. And of course, for the x, for the position, right? So for position, use, right? xf is equal to x initial plus VIT plus 1/2 AT squared to get x of t, right, for each mass. Okay? Therefore, for M1, right, we have x final is equal to, right, x initial, right, plus VI 1t plus, right, 1/2 A1t squared, which is equal to x of t1 is equal to 0, right, 0, because it starts at 0, plus VI, which is 0, right, this is 0, this is 0, plus 1/2 times, right, 3t squared, right, and then for M2, you get x final is equal to x initial to VI 2t plus 1/2 A2t squared. Therefore, x2 t is equal to, you actually have 3 plus 0, because this goes to 0, plus 1/2 times, right, a, which is 6 t squared. So this is 3 plus 3t squared. Right? So you can actually plug that in to your x sub Cm, right? And that is equal to m1x1 plus m2x2 over m1 plus m2. And that is equal to, right, 1 times, you get 3 halves t squared plus 2 times, right, you have 3 plus 3t squared, whole thing over 3. So that should come out to, if you do it correctly, you get something like 1/2 t squared plus 2 plus 2t squared as your, so x sub Cm, that comes out to 2 plus, right, 2.5 t squared as your position function for your center of mass. All right, sorry for going over 2 minutes, but that's it. Now do the next page for homework, as well as other homework pages, such as problems 13 and 19. Okay, 13 and 19. So good luck. All right, I'll see you guys
Thank you.
Thursday.
Thank you.
Bye.